Students, today we will discuss a topic that is concentration of solution. And this topic comes in two chapters. The name of the first chapter is some basic concepts of chemistry, and there is another chapter, solutions. So same topic in the two chapters with same depth, same level of numericals, and everything will be the same. So I'll start the topic, but before it we have to just recall what is the meaning of the term solution. What is meaning of the term solution? We have done this term in the lower classes somewhere in 9th or 10th. So just discuss. In the summer season we normally made a mixture. Just see out what will I take. We take sugar, we take water, some common salt and lemon juice. Lemon juice. Now listen student, the state of sugar is solid, water is liquid, common salt is solid, lemon juice is liquid. Means we are having two states, solid and liquid. But when we mix them, then what will I get? The whole solution comes out to be in liquid state. Which state? Liquid state. And this whole is said to be the solution. Now before I define the solution, just see out what is the meaning of solution. When we mix these substances, sugar, water, common salt and lemon juice, clear? What I got the whole solution in which state? Liquid state. So that particular mixture that I got is said to be the solution. But this is which type of mixture? Remember, or I'll write here, that will be better, homogeneous mixture. Solution is a homogeneous mixture. Why homogeneous? I will again write, because the whole solution comes out to be in the liquid state. Homo means same, geneous means you can say physical state. When the whole comes out to be in the same phase. We have taken sugar, we have taken liquid, water, sugar solid, common salt solid, lemon juice again liquid, but the solution comes out to be liquid. So when the whole mixture comes out to be in same state, that is said to be the homogeneous mixture. So what is solution? First part of the definition, it is the homogeneous mixture of two or more substances. First part, two or more substances. Now I am having 1, 2, 3 and 4 substances. Now listen one more thing now student. I can increase the amount of sugar. Okay, I can increase the amount of water or even decrease the amount of water. I can increase the amount of common salt or even I can increase the amount of lemon juice and all these things. But I can increase or decrease these amount within limits. Limit in the sense, suppose this is a complete glass of water. Okay, so how much sugar I will add? I will add 1 teaspoon of sugar. I will increase this amount, so I will add 2 teaspoons of sugar. Means I can change the proportion of the sugar. Similarly, I can change the proportion of any substance. But is it possible to add 10 teaspoons of sugar? Is it possible? This is not possible. Here it means we have to change their proportion. We can change their proportional amount, but within limits. Limit means I can add 1 teaspoon of sugar. By changing it, 2 teaspoons may be added, but 10 teaspoons of sugar cannot be added in 1 glass of water to form a solution. So complete definition comes out to be better. Solution is a homogeneous mixture of two or more substances whose proportions may be varied within limits. Means हम कम ज्यादा कर सकते हैं, हम शुगर को बढ़ा देंगे, नमक बढ़ा देंगे, बट उतना ही कर सकते हैं लिमिट के अंदर जितना डिसॉल्व होकर क्या बनाए, सॉल्यूशन बनाए। और सॉल्यूशन भी ऐसा सैचुरेटेड सॉल्यूशन, बी क्लियर, विच टाइप ऑफ सॉल्यूशन, सैचुरेटेड सॉल्यूशन। दिस इज क्लियर टू ऑल ऑफ यू, क्लियर। सो डेफिनेशन एक बार फिर से बोलते हैं, बिकॉज इन द 11th क्लास द टॉपिक्स मस्ट बी क्लियर टू यू। सॉल्यूशन इज अ होमोजेनियस मिक्सचर of two or more substances whose proportions may be varied within limits. This is very important point. Now student, come to the next point. I have used these substances for making the solution. These are said to be the components of solution. You got my point? Component of solution: sugar, water, common salt, lemon juice. So what is the meaning of components of solution? These are the substances which form solution. The short form of solution we can simply write SOL on the upper side N. So what do you mean by components? These are the substances which form the solution. So two things students we have done. We have done the definition of solution, and we have done something information regarding the component of solution. Now then we will do types of component of solution. Types of components of solution. Listen student, there are two types. Number one, solute, and second is solvent. Means out of these component we are having solute and solvent. So first we have to understand which component will behave like solute and which component will behave like solvent. Very important. So this will I'll explain here on the board. On the one side this is solute, on the other side this I'll write a little one more this side, solvent. So now listen students. First of all I start with the symbolic representation. The solute is represented by B. Means if B is written with any symbol, that symbol resembles the solute. Suppose I have written WB. So this will, listen, what is W is the symbol of mass and B for solute. So this will be the mass of solute. Understand now? Similarly, if I go to the solvent part, this is symbolized by capital A. If I write WA, it means mass of solvent. And you know that solution, I'll write here, these solute and solvent, that is B plus A, they will combine to form solution. Solution is symbolized by capital S, and if no symbol is given, it means again the data belongs to solution. So first of all, symbol is clear to all of you. Solute is symbolized by B, solvent is symbolized by A. Now listen to the first one. What do you mean by solute? It is a substance which dissolves in other. I start with the very lower, you can say just from the ground. Solute क्या होता है? It is a substance जो दूसरे में dissolve होता है. Just like sugar and water. बेटा क्या water sugar में dissolve होता है या sugar water में dissolve होता है? We well know that sugar dissolve in water. Similarly, common salt water में dissolve होगा या water common salt में? Common salt dissolve in water. Similarly, lemon juice dissolve in water. So by this definition जो हमारे solute आए, these are sugar, common salt and beta lemon juice. Now solvent. This is the component which dissolves other, means जो दूसरे substances को अपने अंदर dissolve करता है. तो I think this capability is only of water here, because water has the capability to dissolve sugar, common salt and lemon juice. So by this definition the solvent comes out to be water. Understand? This thing you have to remember in numericals very much. In the numericals, you have to read the line and you have to understand that the data given to you is of solute or of solvent. Very important data. And this is just for understanding. This is not for the examination part that the teacher will say, what do you mean by solute, what do you mean by solvent. Okay, come to the second point now. Now the second point says, solute is the component which is present in less proportion, whereas solvent is the compound or component which is present in more proportion. So listen, before I start the discussion, I want to tell you one thing, that solvent is always 1. Remember this point? Solvent is always, you can write 1, O-N-E. Whereas solute may be 1 or more than 1. This thing that you have to resemble in your mind, and I think this is clear for the example. By this example, here we have take only one solvent, water, and solute are sugar, common salt, and lemon juice. So be clear in your mind, whatever be the solution, whatever be the number of components, 2, 3, 4, whatsoever, solvent is always 1, not more than 1, whereas solute may be 1 or more than 1. So just to see out, less proportion solute, more proportion solvent. So just see out बेटा, अगर हम इसी solution का discussion करते हैं, ठीक है ना, this is a very common solution जो हम गर्मियों में during the summer season बनाते हैं, ठीक है. So I think इसमें जो maximum proportion है वो किसका होगा, water का. तो due to maximum proportion water will act as solvent. So again by the definition the solvent comes out to be water. Now the 3 components are left which are less than this component. So all 3, that is sugar, common salt and lemon juice, these are said to be the solutes. Again same example, I write sugar, common salt and lemon juice. So 2 definitions we have done, how to identify the solute and solvent. Now I'll shift to the third and the last one, that is number 3, solute. But listen student, before I start the third definition, be clear that your distinguish between the solute and solvent is on the basis of all these 3 points. You cannot distinguish on the basis of 1 point. So just be clear in the numerical that you have to correlate all these 3 points to distinguish or to identify the solute and solvent. So third part, solute, component whose physical state is different from solution. So I just rub out this because we have to explain on the basis of this concept also. Whose physical state is different from solution, and solvent, component whose physical state is same as that of solution. Clear? So just see out, the physical state of solution is liquid. Now see, how many liquids are there? I am having water liquid, I am having lemon juice liquid, this is L, okay, and sugar and common salt, they are solid, means their physical state is different from solution. So beta sugar will be the solute and common salt will be the solute. बस मैं खाली इस point पे rely नहीं कर सकता. I cannot depend on this point because the main point in the starting I have told you that solvent is always 1. Now how many solvent? Water and lemon juice. No doubt 2 are clear, sugar and common salt. I can make a tick, no issue. But what is the issue? There are 2 solvents, but the solvent is always 1. So I'll go on the upper definition. Out of water and lemon juice, which is in less proportion? Lemon juice. Or come to this point, which is in more proportion? Water. So water being more proportion, this will be the solvent, and this, since it is less than water, this again will act as solute. So be clear. So because the last definition sometimes confuses us, therefore I have written this definition at the last. But be remember, the solvent is always 1, solute are 1 or more than 1. So this is, we have done that. How many types of components? There are 2 types of component. One is solute, another one is solvent. The thing that you have to remember, solute is symbolized by B. It may be one or more than one. While beta solvent is symbolized by A. This is one only, not more than one. Now listen, next that I do is types of solutions. That how many types of solution I am having, just listen carefully. Types of solutions. Types of solution on the basis of number of components. Means how many components I am having. So your solution is divided into three categories. Number one, binary solution. Number two, ternary solution. And number three is quaternary solution. Okay, just see. Binary solution. This is a solution which is made up of two components. Ternary solution, it is made up of three components. Quaternary solution, it is made up of four components. Simple definition. Just see out now. Two components. I take the example. That is sugar plus water. Clear to all of you? Now this solution is said to be binary solution. Now see which is solute, which is solvent. Out of sugar and water, which will be in maximum quantity? Water. So water will act as solvent, whereas sugar will act as solvent. Understand? Now I take the example of ternary solution which contain three components. So what will I take? Sugar plus water plus beta common salt. Now see, out of sugar, water and common salt, which is present in maximum proportion or more proportion? Water. Water being present in more proportion, this will act as solvent, while the remaining two, they will act as solute. Understand? Just see these two examples. Here solvent is 1, here also solvent is 1. Now the quaternary solution. I take the example here. Sugar plus water plus common salt plus lemon juice. Now out of these four components, water is present in maximum proportion. Clear? Or you can say more proportion. So water will act as solvent and all other they will act as solute. Clear? Now see one more thing. In binary solution, one solute, one solvent. In ternary solutions, two solute, one solvent. In quaternary solution, three solute, one solvent. Clear indication? Solvent is always one. Solvent may be one, or you can say more than one. So this what we have done, student, we have done regarding the basic information of solution. So you have done the types, you know about solute and solvent. But before I go to the main topic, that is concentration, I will again define solution. Solution is a homogeneous mixture. Homogeneous mixture means the whole comes out to be in liquid state. Clear? Made up of two or more compounds. At least how many compounds are needed? Two compounds. Because one is solute, one is solvent. So solution is a homogeneous mixture of two or more compounds whose proportions may be varied within limits. Means I can increase the amount of particular component or I can decrease the amount of particular component within the limits. Okay. Now I will come to the main topic of today, that is concentration of solution. Concentration of solution. Now see what is the meaning of this term. Concentration. Concentration of solution. Now see student, before I start the topic, just listen one thing, that your solution contains two things, solute plus solvent. So concentration means, just see out, you have to calculate solute. What you have to calculate? Solute. Or I will say concentration means parts of solute. Therefore I have written B. So remember, in concentration always we calculate solute. Either we will calculate the mass, we will calculate its mole, we will calculate its molecule, whatever we calculate. But concentration always means we have to do or we have to calculate the solute. ठीक है ना? In various concentration time, sometime we will calculate mass, sometime we will calculate moles, but since the concentration term is not specified that we are using which concentration term, हम किस term को use कर रहे हैं, तो common term क्या लेंगे? Parts of solute. तो concentration means part of solute, either in solvent or in solution. Clear? Because the solute is present in two cases, solvent and solution. So concentration definition is clear to all of you. Concentration simply means parts of solute either in solvent or in solution. Now listen, the 99% concentration term are calculated in solution. Only one term calculated in solvent. Therefore, I mention here specially molarity. Its symbol is small m. This is the concentration term in which the solute parts are calculated in solvent, while all other terms, all other means percentage, molarity, ppm, strength, normality, mass fraction, mole fraction, ppb, ppt, all these terms they will be calculated in solution. Clear? So one term we will calculate in solvent, that is molarity. Okay, so now what happens? We'll start the concentration term, and remember one thing, concentration means part of solute, that is B. We have to calculate the part of solute either in solvent or in solution. So just see the first method of expressing the concentration. I'll start with the first one, that is mass fraction. The first is mass fraction. What is the meaning of this? Now listen students, suppose I am having two components, simple say sugar, or you can say two components A and B, you well know. So mass MF, remember, mass fraction of A, it means it is the ratio of mass of A upon total mass of all the components, that is mass of A plus mass of B. Similarly, I can calculate mass fraction of B. So what will be? It will be the ratio of mass of B upon mass of A plus mass of B. So how can I define the mass fraction? So mass fraction is the ratio of mass of component, since if I want to calculate the mass fraction of A, then on the upper side mass of A. If I want to calculate the mass fraction of B, then on the upper side it will be B. So it is the ratio of mass of component to that of total mass of all the components. I think definition is clear to all of you. Clear? Now listen, one more thing. Units. Since it is a ratio, so there are no units. Remember this point. Understand now? Now. As far as units is concerned, clear? And one more thing. Listen student, we know that the sum of percentage is 100. Clear? Similarly, the sum of fraction, whatever be the fraction, sum of fraction, whatever be, it will be mass fraction or whatever it is, sum of mass fraction is 1. What does it mean? It means in this example, mass fraction of A plus mass fraction of B, that is equal to 1. Now what is the benefit of this? If I know the mass fraction of one component, then I can calculate the mass fraction of other. How? Now mass fraction of A. How this comes out to be 1 minus mass fraction of B. Similarly, mass fraction of B will be 1 minus mass fraction of A. So this is clear to all of you. Mass fraction, simply say it is the ratio of mass of particular component to the total mass of all the components having no units. And remember, the sum of mass fraction, this is always 1. Okay, now we'll do the numericals on this mass fraction. Simple numericals are there, just see out. A solution contains 40 gram NaOH dissolved in 60 gram water. 40 gram NaOH dissolved in 60 gram water. Calculate mass fraction of each component. What I have to calculate? Mass fraction of each component. So see the solution. But your solution contain how many components? It contains 40 gram of NaOH plus 60 gram of water. Clear? Now see which is present in more quantity, 40 or 60. I think this is more. So this will act as solvent and this will act as solute. Understand beta? Okay, now mass fraction of NaOH. How can I calculate? Understand now. What is the mass of NaOH? This will be equal to mass of NaOH upon mass of NaOH plus mass of water. So mass of NaOH is beta 40 upon mass of NaOH plus mass of water is 60. This will be 40 upon 100, comes out to be 0.4. Clear to all of you? Simple numerical, no issue. Now mass fraction of water. There are two methods to solve. First I am using this method, that it is the ratio of mass of water upon beta mass of water plus mass of NaOH. See, what is the mass of water? 60 upon mass of water 60 plus mass of NaOH 40, comes out to be 60 upon 100, 0.6. This is the first method. We can use one more method. We know that mass fraction of NaOH plus mass fraction of water is 1. Clear? So from here the mass fraction of water comes out to be beta 1 minus mass fraction of NaOH. So 1 minus beta 0.4, this comes out to be 0.6. Same. Clear to all of you? Now this is the way that we have calculated that particular mass fraction of NaOH and mass fraction of water. Clear to all of you? First example. And one more thing that you have to remember, that this is a hint how to check your numerical. How to check your numerical regarding the fraction. The sum of mass fraction is always 1. So check out. 0.4 plus 0.6 comes out to be 1.0. It means the answer is correct. If this will not be equal to 1, it means there is some mistake. Check the numerical again. Okay. Now this is about the mass fraction. First numerical we have done. Now we'll do the second numerical. Question number 2. A solution contains 1 mole each of NaOH in water. A solution contains 1 mole each of NaOH in water. Calculate mass fraction of each component. Okay, so this is the solution. Our solution contains 1 mole NaOH plus 1 mole water. Now see students, we have done the mole concept. Okay, and according to mole concept, 1 mole will have the mass that is equal to molar mass in grams. Am I clear to all of you? So what is the mass of NaOH? The mass of NaOH, you know, sodium is equal to, I can simply say its molar mass, that will be equal to 23 plus 16 plus 1 comes out to be 40 gram. This is clear. What is the mass of 1 mole? The mass of 1 mole is equal to molar mass in gram that we have calculated, or this we have done in the mole concept. I can write this we have done in mole concept. Listen student, in the chemistry the articles are interrelated. If you don't know the mole concept, then there will be obviously difficulty in solving the numericals of this topic, that is concentration. So this will be the mass of NaOH. Similarly, we can calculate mass of water. This will be again equal to molecular mass. This comes out to be 2 into 1 plus 16, 18 gram. Okay. So from the moles we have calculated the mass. Now we can apply the formula. Mass fraction of NaOH. This will be equal to beta mass of NaOH upon mass of NaOH plus mass of water. Okay. So what is the mass of NaOH? 40 upon mass of NaOH is 40 plus mass of water is 18. So this comes out to be 40 upon, if you will add 8 and 0, 8, 4 and 1, 5. If you will short divided by 2, this will be 20. This will be 2 2s are 4, 2 9s are 18, that is 20 upon 29. When you will divide, this comes out to be x. Okay, do the divisions, because now you are able to divide. In the last lecture you have done so many numericals that this multiplication division word you will do yourself. I'll simply make it as x1. Okay, now mass fraction of water. First I will use same mass of water upon mass of NaOH plus mass of water. Now what is the mass of water? Beta 18 upon mass of NaOH 14 plus 18, that is 18 upon 58. Again on dividing by 2, this will be 9 and this will be 2 2s are 4, 2 9s are 18. This will be your x2. Okay. Now the one more way of calculating mass fraction of water. 1 minus mass fraction of NaOH, that is equal to 1 minus, you can write 20 upon 29, or 1 minus x1 if you have calculated this value. Okay. So how can I check that this question is accurate or wrong? Remember, the sum of mass fraction of water plus mass fraction of NaOH, this comes out to be 1. What does it mean? It means 20 upon 29 plus 9 upon 29. This comes out to be 1. Shall we check? Okay, we can check now. This is one of the easiest one. What is the LCM of 29 and 29? 29. So this will be 20 plus 9 equals to 29 upon 29, 1. It means our answer is correct. Clear to all of you? Since this is a mass fraction, we can also show it in fraction also. And total mass fraction comes out to be 1. It means our answer is correct. That is, the mass fraction of NaOH is 20 upon 29, whereas the mass fraction of water is 9 upon 29. Okay. Now the third question on this mass fraction. A solution contains 40% NaOH. Solution contains 40% NaOH plus 36% water, and you can say 24% calcium carbonate. Clear? Solution contains 40% NaOH, 36% water and 20% calcium carbonate. Calculate the mass fraction of each component. Calculate the mass fraction of each component. Again, same, just listen, student. You know that percentage is calculated in how many parts? 100 parts. If a solution contains 40% NaOH, 36% water, 24% CaCO3, so I can say that your solution is how many parts? 100 parts. From this 100, the 40% is NaOH, means mass of NaOH I will take 40 gram. Similarly, mass of water, this will be 36 gram. Similarly, mass of CaCO3, this will be beta 24 gram. This is clear to all of you now? Any doubts? Okay, now see. What is, since we are having 3 components, this is said to be ternary solution. Clear? Okay, now see. Mass fraction of NaOH. First I will calculate this, then mass fraction of water, and the last mass fraction of CaCO3. This I will calculate. Now first I write the formula. The mass fraction of NaOH, this is equal to mass of NaOH upon beta mass of NaOH plus mass of water plus mass of CaCO3. On putting, mass of NaOH is 40 upon NaOH 40 plus water is 36 plus CaCO3 is 24. Okay, so this will be equal to beta 40 upon 100 and comes out to be 0.4. Clear to all of you? Similarly, we calculate mass fraction of water. The formula is mass of water divided by mass of water plus mass of NaOH plus mass of CaCO3. Now mass of water is C out 36, mass of water 36 plus mass of NaOH 40 plus CaCO3 24. So this will be beta 36 upon 100 comes out to be 0.36. Understand? First is 0.4, second is 0.36. Now third one, mass fraction of CaCO3. This is again I will write mass of CaCO3 upon mass of CaCO3 plus mass of NaOH plus mass of water. CaCO3 is 24 grams upon beta mass of CaCO3 24 plus NaOH 40 plus water 36. This will be 24 upon 100, that is 0.24, 1, 2 and 3. Now how will I check that our numerical is correct? Again the same thing, the sum of mass fraction comes out to be 1. So how to check? Just simply 0.4 plus 0.36 plus 0.24. Simply add 6 and 4, 10, 1 carry. 4, 5, 6, 7, 8, 9, 10, 1 carry, 1.0. That our solution is exactly correct. So this we have calculated by using the percentage. Now one more question we will do for that mass fraction. Just see out. A solution contains you can say that is 3.011 10 raised to the power 20 3 molecules of NaOH and 6.022 10 raised to the power 20 3 molecules of water. Okay students, calculate mass fraction of each component. What I have to calculate? I have to calculate the mass fraction of each component. Now see, what is given to you, just understand. This is a numerical which include more concept. Clear to all of you? So you have given solution contains NaOH plus water. Now listen student, if I want to calculate the mass fraction of NaOH, then this is equal to mass of NaOH upon mass of NaOH plus mass of water. I want this data. Similarly, if I want to calculate mass fraction of water, then I need mass of water upon mass of water plus mass of NaOH. But see the question. I think in the question mass is not given. What is given? Molecules. What are given? Molecules. So we have to convert the molecules into the mass first. What we have to do? We have to convert the molecules into mass first. What are given? 3.011 10 raised to the power 20 3 molecules of NaOH is given, are given, and 6.022 10 raised to the power 20 3 molecules of water are given. This is the data given. So what we have to do? I have to convert the molecules into the mass. Same more concept. Molecules are given, mass I have to calculate. So mass upon molar mass equal to molecules upon 6.022 10 raised to the power 23. So mass I have to calculate upon molecular mass of NaOH is 40. Molecules are given 3.011 10 square 23 upon 6.022 10 raised to the power 23. On cutting, this comes out to be 1 by 2. And to this side, the mass comes out to be 40 by 2. That is 20 gram of NaOH. Now this is very important, students. If you don't know the mole concept, then it is very difficult. So whenever you see the difficulty in any lecture, just go through the previous lectures. Okay, na? Clear to all of you? Now similarly, we will calculate the mass of water. What it comes? See out. Again, mass upon upon molar mass, this will be equal to molecules upon 6.022 to 10 raised to the power 23. Now mass I have to calculate. Molar mass of water is 18 gram. How many molecules are given? 6.022 10 raised to the power 23 upon 6.022 10 raised to power 23. On cutting, this comes out to be 1 by 1. So mass of water is 18 gram. Now I got the mass, so I calculate our mass fraction. I will calculate the mass fraction of NaOH. The mass of NaOH is 20 upon the mass of NaOH 20 plus water is now 18 gram. So this will be 20 upon 8 and 0, 8, 38. On simplification, this comes out to be 10, and 2 ones are 2, 2 nines are 18, 10 by 19. Okay, clear? Now, mass fraction of water. You can solve it in decimals and you can mark the answer as A1. Okay, this will be try yourself. Similarly, now, the mass fraction of water. What is the mass of water? 18 upon mass of water 18 plus NaOH is 20. So this will be 18 upon 38. So what this comes out to be? This will be 2 nines are 18 upon 19. Clear? This will be 2 nines are 18, 2 ones are 2, 2 nines are 18. This is A2. Clear to all of you? Mass fraction of NaOH is 10 by 19, mass fraction of water is 9 by 19. Now how will I check that this is the correct answer or not? I simply add 10 by check. How will I check? So if I add 10 upon 19 plus, where it is 9 upon 19, 19 will be the LCM. 10 plus 9 comes out to be 19 upon 19, 1. This is clear to all of you students? This is the way to check. Now listen student, whenever you calculate the mole fraction, try to calculate in decimals also. Clear to all of you? Whatever be the answer, 0 point something something, whatsoever be the calculation. Then again check whether the sum is 1 or not. If the sum is not 1, it means there must be some mistake. So in today's lecture, we have done the introduction of solution. Then solution is what? Homogeneous mixture of 2 or more substances whose ratio may be varied within the limits. Then we have done regarding the components. 2 type of components, solute and solvent. Remember, solvent is always 1 and it is a component which is present in maximum amount. Then we have done binary, ternary, quaternary solution. Binary solution made up of 2 components, ternary 3, quaternary 4. Then what is the meaning of concentration? Concentration means that we have to calculate the parts of solute in either solvent or solution. Clear? And today we have done the first concentration term, that is mass fraction. What is mass fraction? Again I repeat, it is the ratio of mass of component to the sum of mass of all components. Clear? Since this is the ratio, it will have no units. Okay, this is one. So this is all about beta, that is the first concentration term, mass fraction. That's all.